Have you ever wondered what a database was and why you should care? Well, spend the next couple of minutes with me and I'll try and answer these questions. My favorite analogy when explaining a database is to think of a spreadsheet. Most people understand what spreadsheets are, and fundamentally, spreadsheets are really just database is really just spreadsheets on steroids. And it's really a series of spreadsheets. So imagine you have Excel or whatever spreadsheet program you use open, and that spreadsheet had multiple tabs. And on the first tab, you might have all of your customer information. So every customer has their first name, their last name, their address, their phone number, and so on. But there's a key element that you need to add to that customer, and that's a unique identifier for every customer. And so that's usually going to be a number, and databases have these things called sequences or identity columns. And what their function is basically to generate a unique ID, mostly a number, for every customer in the system. And so as the customers get created, the database will assign a new number to them. And so that will be a unique number that you can carry across to other tables in your database. For example, let's say I've got an orders spreadsheet tab, and on the order, I'll have like information about the order, like when the order was placed, so the order date, what product was ordered, the quantity, maybe order total, tax that was applied to the order, and so on. But a key element that you're going to have inside the order table is going to be that customer ID. So you'll have that customer ID, and that's the key, because that tells you all the information about the customer, but all you have to store inside the order is the number. Okay. And then, of course, just like for the customer table, you're going to have an order ID that's going to be assigned to every order in the orders table. And so this allows you to define a database and link all these things together. That's why it's called a relational database, because you have relationships between all of the tables in your database. And what a key fundamental rule of that is that you will have no duplication in your database then, because you're defining your customers once and then you refer to them in all the other tables. And so let's say that you've got like something that's referring to your orders. And so you'd have that order ID that's fundamentally only defined once in your database. So that's why you're defining your database in that manner. So just to drive that point home, think of a database as a series of spreadsheets that are tied together and that have enhanced functionality on top of it that we're going to talk about in just a minute. So I just said that a database is just a bunch of spreadsheets, right? So why not just use a spreadsheet? Well, we'll answer that. Really, spreadsheets are primitive when you compare them functionality-wise to a database. They're error-prone. As data grows, you might run into like row limits. I don't know what the row limits are these days. I do recall like a while back, 2 million rows was a limit of the number of rows you could have in a Excel spreadsheet tab, which is quite limiting. You're going to have database tables that are in the millions or even billions of rows. Spreadsheets also lead to data redundancies, and that leads to inconsistencies in your data. Manual updates across multiple sheets can be a real issue with spreadsheets. And a bunch of functionality that relational database management systems add are SQL. That's a language that's built on top of databases that allow you to interact with the data, to query it, to insert new data, to update it, to delete it, and so on. Databases also add security and access control, so you can create users that can access your database. You can grant privileges to those users. You might have some users that are read-only and some that have read-write capabilities, and others have the ability to alter the structure of the tables in the database. Databases also offer concurrency control. So this is transactions. And so what you'll have is the database will control access to a data element. So let's say that somebody's trying to modify your bank account. Well, you don't want two people modifying your bank account at the same time. You want them to have to go in a specific order so that they're not trampling the data and causing inconsistency in the data. You don't want your balance of your bank account to be wrong. You've also got transaction management. So let's say that I want to update multiple records. You've got two accounts. You've got a savings account and you've got a checking account. And you're going to move your funds from your savings to your checking. Well, you want that all to be in one transaction, because let's say that you deduct $100 from your savings account to put it into your checking account. And if the transaction were to fail midway, you would lose $100 because you would never get the deposit into your checking account. So that's a very important feature of a relational database, is transaction management. Then you've got indexing. That's performance. So I like to explain indexing in terms of, you've got a book. So if you've got a book and you don't have an index, and you're looking for a particular term, you'd have to go through every page of that book and look for that term, which is kind of like what they call a scan in a database. Well, an index allows you to do something like, if you recall, in the back of a book, you go to the back of the book and you've got an index and you look for a term and it tells you what page that term appears on. Well, that's all an index is in relational database. And it's much faster to do that than to go and page through every page of the book. And so that's a real simple way of explaining indexing. You also could do maintenance and automation. Most databases have some sort of like job system that gets built in. And so you can schedule things like backups and maintenance of your indexes, or database checks, integrity checks on your tables, or even like jobs that you've created that are more application related, that maybe you're going to load data from an external source, or you're going to move data from one table to another. You can automate all that within your database. You've also got enhanced storage and partitioning. So partitioning allows you to work with very large data sets. And so if you're partitioning a table in your database, you're actually splitting that up. And so the optimizer can say, okay, well, if somebody's only querying data from, say, 2025, I don't need to go through and look at the data in the table that's related to any dates before 2025. And so that's a very, very important performance enhancement that you can build into your database. And then storage allows you to like split your files across your database across multiple files in your system. And so like if you just had an Excel file, all you're going to have is one file in most cases. And you can only grow files to a certain, most operating systems will have limitations on how large a data file can get. You've also got backup and recovery. So it's very important to back up your data, and databases have all kinds of tools, utilities in order to make it a lot easier to back up your database. And of course, there's accompanying recovery functions. Replication is a very popular feature in relational databases, and that allows you to take data from one database and copy it to another one, so that you're not, maybe you have a reporting system or something like that, and you don't want to burden your online system with people hitting with reports, but you want to have up-to-date data. Well, replication fits the bill with that. You've also got high availability features where you can have multiple servers that are able to be running all the time, with one being in a hot mode where they're serving transactions, and the other ones that's receiving the data and can, with a flip of a switch, or maybe you have a failure of that primary instance, can take over and run everything in an almost seamless way. And then you've got all kinds of performance tools that are built on top of databases that allow you to have a good view of how your database is performing, and they aid very much in tuning. Okay, now that you have a better idea of what a database is and some of the functionality that they offer, let's switch gears a little bit and talk about why you should care. Well, you should care because databases power just about every industry you can think of. Databases are used in finance to track transaction data. Databases are used in healthcare to manage patient information, appointments, and treatments. Databases are used within the logistics to optimize routes and inventory across supply chains. Databases are used in education to store student information, their grades, and even course materials. Databases are used in insurance to store claims data, customer policy information, terms and conditions of those policies. And most importantly today, databases are used in AI. Databases are what fuel AI. All of those LLM models that everyone's using on ChatGPT and all the other LLMs today, they're trained on data. And they can't do anything without that data. They're basically using all these past events to learn and predict and forecast the future. Okay, here's just a few careers that you can go into with respect to a database. You could be a data modeler. So that's the individual that basically lays out the database, defines what tables there will be, what the columns are going to be stored in each of these tables, and defines the relationships between those tables. Then you've got a data architect, which is more of a physical architect. So sometimes you'll have a data architect that does the modeling as well, but if you've got a clear separation, data architect deals more with the physical structure of the database and maybe what it's, what sort of hardware it's going to be running on. And so they would make those types of decisions. And then moving on, you've got a database administrator, and this is the individual that maintains, secures, and optimizes the database. So they're going to install the database software. They're going to be responsible for the backups and recovery, and they'll be involved with the setup of any high availability setup that might be in place. And then, of course, you're going to have your database developer and your ETL specialist, and these are the people that are interacting with the data from an application perspective, or they're getting data into and out of the database. So these are just a few examples. There's a lot of other careers that you can pursue, but these are four here, right here, that you can consider. If you're still here, I wanted to thank you for sticking through to the end. I hope you got something out of it. If you have additional questions, hey, I have a Skool community that I have started, and I'll drop this link that's here below in the comments. If anyone would like to join, I'd love to see you inside. Talk to you later.